Today, operators complain if the Bluetooth in the cab disconnects. But just a few decades ago, operating a machine was a game of Russian roulette. If you respect the generation of men who worked without ROPS, sensors, or safety nets, please subscribe. We are fighting to keep their stories from being deleted by the algorithm. We are going back to an era where the only safety feature was your survival instinct, analyzing 10 design features, like the infamous suicide knob, that claimed lives and left scars on an entire workforce. 1. Open cabs, the absence of ROPS FOPS. In the modern world of heavy machinery, the operator sits inside a reinforced cocoon known as the cab. This structure is not just for comfort or air conditioning. It is an engineering marvel designed to withstand the crushing weight of the machine itself. However, for the majority of the 20th century, this protection did not exist. Early bulldozers, graders, and scrapers featured open cabs. The operator sat on a simple metal seat, completely exposed to the elements and, more fatally, to the laws of physics. The specific danger here was the lack of ROPS, rollover protective structures, and FOPS, falling object protective structures. In the early days of earth-moving, stability systems were rudimentary. Machines were often top-heavy, and they were frequently tasked with working on steep gradients, muddy embankments, or unstable logging trails. If a bulldozer working on a slope hit a hidden stump or a patch of loose soil, the center of gravity would shift instantly. Without a ROPS structure, the machine would roll. In an open cab scenario, a rollover was almost a guaranteed death sentence. The operator had a split-second, terrifying decision to make. Try to jump clear of the rolling metal beast, or grip the steering levers and pray. Tragically, many operators attempted to jump. As the machine rolled, the centrifugal force often threw the operator out, or they would slip while trying to leap. The result was that the operator would land on the ground just seconds before the multi-ton machine landed on top of them. Historical accident reports from the pre-1970s are filled with crush injuries caused by equipment turnover. It wasn't until the regulatory push in the 1970s and the development of Society of Automotive Engineers (SAE) standards that the roll cage became mandatory. Before that, the only thing between an operator and the crushing weight of a 20-ton tractor was the open air. Furthermore, without FOPS, operators in open cabs were essentially sitting ducks in logging or demolition environments. A falling tree branch or a loose rock from a quarry face had a direct path to the operator's head, with no reinforced roof to deflect the impact. The open cab era represents a time when the machine's operation was prioritized entirely over the operator's survival. 2. Crank starters, the kickback. Before the universal adoption of the electric starter motor and heavy-duty batteries, starting a massive internal combustion engine was a feat of physical strength and immense danger. This was the era of the hand crank. While we might associate hand cranks with small Model T Fords, the danger was exponentially higher when applied to heavy industrial tractors and early earth movers. To start these machines, the operator had to insert a heavy iron crank handle into the front of the engine, engaging directly with the crankshaft. The operator then had to manually spin the engine to build enough compression for ignition. The danger lay in a phenomenon known as the kickback. Internal combustion engines rely on precise timing. If the spark, in a gas engine, or the compression ignition occurred slightly too early in the cycle, often due to a misadjusted spark lever or a hot engine, the piston would be forced back down the cylinder in the wrong direction before it passed the top dead center. This caused the crankshaft to instantly reverse its rotation with the full force of the engine's exploding fuel. When a massive tractor engine kicked back, the crank handle didn't just stop, it snapped backward with bone-shattering speed and torque. If the operator was holding the handle incorrectly, specifically if they had their thumb wrapped around the handle, the reverse force would drive the handle directly into the palm, snapping the thumb, or more commonly, fracturing the radius and ulna bones in the forearm. This injury was so common in the early mechanical era, it was colloquially known in medical circles as a chauffeur's fracture. On larger machines, the force could dislocate a shoulder or even throw the operator through the air. Experienced operators learned to cup their hands without wrapping the thumb, relying on an open palm so the handle would fly out of their hand if it kicked. However, on muddy construction sites, with wet gloves and exhausted workers, the hand crank remained a notorious maimer of men until electric starters and auxiliary pony motors rendered them obsolete. 3. Exposed flywheels and gears. The unguarded era. The aesthetic of the early Industrial Revolution and the construction equipment that followed it was defined by visible mechanics. Whether it was a steam-powered traction engine from the 1910s or a diesel crusher from the 1930s, engineers felt no need to cover the moving parts. This led to the prevalence of exposed flywheels and open gears. A flywheel on an early tractor or steam shovel is a massive, heavy iron wheel designed to store rotational energy and keep the engine running smoothly. These wheels often spun at high speeds just inches from where the operator stood or walked. Alongside these flywheels were often exposed gear trains, teeth of steel meshing together with thousands of pounds of crushing force to drive tracks, cables, or winches. The danger was insidious because it was constant. Construction sites are loud, vibrating, and chaotic. An operator or a ground crewman wearing loose clothing, such as an unbuttoned jacket, a baggy sleeve, or even a glove, needed only to brush against these exposed components once. The friction of a spinning flywheel could snag fabric instantly. Because of the immense mass and momentum of the flywheel, the machine would not stop or even slow down. It would simply pull the fabric, and the person inside it, into the machinery. In the case of exposed gears, the nip point or pinch point, where two gears met, acted like a mechanical predator. If a finger, hand, or pant leg was caught in the in-running nip, the gears would pull the limb in relentlessly. There were no emergency stop buttons within reach, and certainly no sensors to detect an obstruction. By the time a co-worker realized what was happening and killed the engine, the damage was often catastrophic. The era of exposed gears required a level of hypervigilance that was impossible to maintain 100% of the time, leading to horrific amputations and fatalities that eventually forced manufacturers to encase all moving parts in sheet metal guards, a safety standard written in blood. 4. Cable-operated controls. The knuckle busters. Before the widespread adoption of smooth hydraulic systems, the earth-moving industry relied heavily on cable operation. From the 1930s through the 1950s, the blade of a bulldozer or the bowl of a scraper was not lifted by fluid pressure, but by a complex system of steel cables, sheaves, and winches. These systems, often known as power control units, PCUs, were mechanically efficient but physically brutal for the operator. The primary interface for these systems was a set of long, heavy steel levers located next to the operator's seat. The danger of cable controls lay in the direct mechanical feedback. Unlike hydraulic valves, which isolate the operator from the external forces acting on the machine's blade, cable levers were mechanically linked to the clutches and brakes of the winch. This meant that the immense tension on the cables could transmit energy backward through the system. The most notorious hazard was the kickback of the control lever. If the cable snagged, or if the blade suddenly hit an immovable object like a buried boulder while the clutch was engaged, the tension in the drum could spike instantly. This force would override the operator's grip and snap the heavy steel lever backward or forward with the speed of a whip. Operators called these knuckle busters for a reason. If an operator's hand was in the wrong position, the rebounding lever would smash their fingers against the steel cabin wall or the dashboard. The force was sufficient to shatter knuckles and break fingers. In more severe cases, where operators had to use their full body weight to pull a stubborn lever, a sudden kickback could catch them in the chest or side, cracking ribs. Furthermore, the operation of these levers required constant, high-force physical input. Unlike the fingertip controls of modern joysticks, cable controls required the operator to fight the machine all day. The fatigue generated by this constant wrestling match led to slower reaction times as the shift wore on, increasing the likelihood of the operator failing to anticipate a lever snapback. The Le Tourneau leg. a term sometimes used to describe the bruises and scars on operators who wrestled with the famous RG. La Tourneau cable units became a badge of honor, signifying that you had survived the era of unassisted mechanical warfare. 5. Suicide knobs, the wrist breakers. The suicide knob, also known as a Necker knob or Brody knob, is a small free-spinning knob attached to the rim of a steering wheel. While they became a pop culture symbol of 1950s hot rodders, their origin and their most dangerous application were in the world of heavy utility work and agriculture. In the era before power steering became standard on heavy equipment, steering a grader, a tractor, or a heavy truck required immense physical effort. To turn the wheels of a stationary or slow-moving grader from lock to lock might require several full rotations of the steering wheel. To facilitate this, operators attached these knobs so they could spin the wheel rapidly with one hand while operating gear levers or blade controls with the other. It seemed like a practical solution to a mechanical limitation, but it introduced a severe kinetic hazard. The danger arose from the lack of hydraulic damping in the steering systems. In a modern vehicle, if a front tire hits a pothole, the power steering system absorbs the shock. In old mechanical steering boxes, that force was transmitted directly up the steering column to the wheel. If a tractor or grader traversing rough, uneven terrain hit a deep rut, a stump, or a large rock, the front wheels would be violently forced to the side. This caused the steering wheel to spin uncontrollably and with incredible speed. If the operator was gripping the steering wheel rim, the friction might burn their hands, but they could let go. However, if the operator was using a suicide knob, the knob became a high-velocity projectile moving in a fixed orbit. If the steering wheel whipped around, the protruding knob could strike the operator's wrist or forearm with the force of a hammer strike. Broken wrists were the most common injury, but the knob could also catch a sleeve and entangle the operator's arm in the spinning wheel, leading to dislocations or fractures of the radius and ulna. In the erratic, bumping environment of a construction site, these knobs turned the steering wheel into a bone-breaking weapon, leading to their eventual prohibition in many commercial and industrial jurisdictions. 6. Friction clutches, the thermal fade and dropped loads. In the modern era of hydraulics, lifting a load is a matter of fluid dynamics. When an operator stops moving the joystick, a valve closes, trapping oil in a cylinder. The load is held by the incompressibility of the fluid. It is a positive, physical lock. However, for much of the 20th century, hoisting was controlled by friction. Cranes, draglines, and cable-operated shovels relied on massive drums wrapped with friction bands, essentially giant brake pads, to lift and hold tons of steel and concrete. The mechanism was simple but perilously fragile in practice. To lift, the operator engaged a clutch to spin the drum. To hold or lower, they used a foot pedal or hand lever to tighten a brake band around the outside of the drum. The danger arose from the intense heat generated during this process. On a busy construction site, a crane operator might be cycling loads continuously. Every time the operator feathered the brake to lower a steel beam into place slowly, the friction generated immense heat. In older machines, these friction linings were susceptible to a terrifying phenomenon known as thermal fade, or glazing. As the brake band heated up, the material would expand, and its coefficient of friction would plummet. The lining would become hard and glass-like, losing its ability to grip the steel drum. Suddenly, and often without warning, the brake would effectively vanish. An operator could be standing on the brake pedal with all their weight, but the drum would slip. This led to the catastrophic dropped load scenario. A multi-ton concrete bucket or steel girder would suddenly free fall. In the panic of a slipping brake, the operator might try to slam the engagement clutch to catch the load, but the shock load of catching a free-falling weight often snapped the boom or the cables, causing the entire crane structure to collapse. This mechanical limitation forced operators to work by feel and smell, sniffing for the acrid scent of burning lining to know when they were pushing the machine too far, a margin of error that frequently proved fatal for ground crews working below. 7. Lack of backup alarms. The silent giant. It is a sound so ubiquitous in modern society that we often tune it out. the rhythmic beep, beep, beep of a heavy vehicle reversing. Yet this sound is a relatively recent innovation in the timeline of construction history. Before the mid-1970s, and the subsequent strict enforcement by agencies like OSHA, Occupational Safety and Health Administration, massive construction vehicles had no auditory warning system when moving backward. The lethal geometry of heavy equipment made this absence devastating. Machines like off-road haul trucks, wheel loaders, and motor graders have massive blind spots to the rear. The operator, perched high up in a forward-facing cab, often has zero visibility for tens of feet directly behind the machine. The engine housing, the radiator, and the sheer size of the dump bed create a visual wall. Without backup alarms, the safety of the site relied entirely on visual vigilance. However, construction sites are acoustically chaotic environments. The roar of diesel engines, the clatter of jackhammers, and the grinding of tracks create a wall of white noise. A worker standing behind a stationary dump truck might not hear the engine RPM increase as the driver prepared to reverse, because the noise was drowned out by a compressor running nearby. The result was a horrific epidemic of struck-by fatalities. Workers, surveyors, and even other machine operators walking on the ground were crushed simply because the driver didn't know they were there, and they didn't know the driver was moving. The tragedy of these accidents was often compounded by the size of the tires. A worker could be run over by a scraper, and the operator might not feel the bump due to the machine's suspension and massive weight, continuing on unaware of the fatality they had just caused. The introduction of the audible reverse alarm was a turning point, shifting the responsibility of warning from the ground worker's eyes to the machine's automatic systems. 8. Asbestos brake linings, the mechanic's killer. While most dangerous features on this list killed quickly, through crushing, falling, or impact, this feature killed slowly, decades after the exposure. For a large portion of the 20th century, asbestos was considered the miracle material of the automotive and heavy equipment industries. It was cheap, durable, and, most importantly, virtually impervious to heat. As mentioned in the section on friction clutches, heavy machinery relies heavily on braking systems that generate intense thermal energy. Asbestos was the primary component in brake shoes, clutch plates, and gaskets for bulldozers, cranes, and tractors. While the material posed a minimal risk while trapped inside the brake assembly during operation, it became deadly during maintenance. The brake job was a routine task for heavy equipment mechanics. When a tractor came in for service, the mechanic would remove the heavy iron drums to reveal the brake shoes. Inside, they would find a thick accumulation of brake dust, the ground-up residue of the asbestos lining that had worn off during use. To clean this out and inspect the parts, the standard procedure for decades was to take an air hose and blast the assembly with compressed air. This action created a cloud of millions of microscopic, needle-like asbestos fibers. These fibers are friable, meaning they easily crumble into dust that can be inhaled deep into the lungs. The mechanics, often working in poorly ventilated shops without respirators, would stand in this gray cloud, breathing in the dust. The fibers would lodge in the lining of the lungs, the pleura, leading to asbestosis and mesothelioma, an aggressive and incurable cancer. The tragedy of asbestos brake linings is that the danger was invisible. A mechanic could work their entire career feeling healthy, only to develop a persistent cough 20 or 30 years later. The use of asbestos in brake linings has since been banned or heavily restricted in most developed nations, and modern maintenance procedures now require wet cleaning methods and hazmat suits. But the legacy of the miracle mineral remains a somber chapter in the history of equipment maintenance. 9. Manual pin hitching, the crush zone. In the modern agricultural and construction landscape, connecting an implement, like a scraper, a plow, or a heavy trailer, is often done with automatic hydraulic couplers or precise three-point hitches that can be managed from the safety of the cab. However, for decades, the industry standard was the drawbar and pin system, a method that required a terrifying level of trust and coordination between two people. The mechanics were rudimentary. The tractor had a heavy steel drawbar with a hole in it, and the implement had a corresponding tongue. To connect them, the holes had to be perfectly aligned so a massive steel pin could be dropped through. Because these implements were often too heavy to move by hand, the tractor had to be reversed into position with millimeter precision. This necessitated a ground worker, often a junior apprentice or the farmer's son, standing directly between the reversing multi-ton tractor and the stationary iron implement. This area is known in safety engineering as a crush zone or pinch point. The ground worker would stand in the gap, signaling the driver to back up. The danger lay in the primitive nature of the clutches and transmissions of the era. Old tractors did not inch smoothly like modern hydrostatic drives. They often lurched. If the operator's foot slipped off a heavy clutch pedal, or if the machine surged over a bump in the ground, the tractor would jump backward instantly. The person standing in the gap had nowhere to escape. If the tractor pinned them against the implement, the results were almost always fatal, resulting in severe internal crushing injuries to the pelvis or torso. Even if the driver stopped in time, the manual insertion of the pin posed a risk to hands and fingers. If the equipment shifted or rolled on uneven ground while the worker was guiding the pin, it could shear off fingers like a guillotine. The transition to automatic pickup hitches and the strict prohibition of standing between reversing vehicles and stationary objects has virtually eliminated this specific type of workplace tragedy. 10. Vertical exhaust stacks without rain caps. The black rain. The silhouette of a classic bulldozer or farm tractor is often defined by the vertical exhaust stack protruding from the hood. While iconic, the design of these early exhaust systems, combined with the open cab environment mentioned earlier, created a unique and hazardous environment for the operator known as the black rain. In early diesel engineering, engines were not the clean-burning power plants we have today. They produced significant amounts of particulate matter, soot, unburnt fuel, and hot sparks. On many early machines, the exhaust pipe was simply a straight vertical steel tube with no curvature at the top and no rain cap, the little flapper lid seen on later models. The design flaw was aerodynamic. As the machine moved forward, or if the wind blew from the front, the exhaust plume was blown directly back into the operator's face. This was not merely an annoyance, it was a physical hazard. The stack slobber, a mixture of oil and soot, would rain down on the operator. This hot, oily substance could cause burns and severe eye irritation, blinding the operator temporarily while they were controlling heavy machinery. Furthermore, early engines, particularly those that were working hard under load, would frequently eject burning embers or sparks of carbon buildup from the stack. In an open cab, these sparks would hit the operator's face and clothing, posing a constant risk of corneal burns or setting oil-soaked work clothes on fire. Beyond the immediate physical trauma, the long-term health effects were devastating. Operators were essentially breathing directly from the tailpipe for 10 to 12 hours a day. The inhalation of raw diesel exhaust, rich in carbon monoxide, nitrogen oxides, and carcinogenic particulates, led to operators' fatigue, chronic headaches, and long-term respiratory diseases. The introduction of the rain cap and curved exhaust tips, which directed smoke away, followed by the mandated enclosed cab with air filtration, finally allowed operators to breathe clean air while they worked. Looking back at these features isn't just about mechanics. It is about understanding the blood price paid for the safety standards we have today. It's not just about the steel. It's about the men who risked it all. Don't let their legacy fade into history.